Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Now, Nigel sent us an email in about optical and how practical it might be to send light from headlights further ahead via fibre optics to define dark or unlit roads, especially round bends. When the headlights are pointing at the side of the road, the mechanics of the new cat's eyes could be simple enough. And he says, could you use fibre optics to produce cat's eyes that go round corners?
It's a very interesting idea. So I guess what he's suggesting is a fibre optic is a very long thin piece of glass, or even plastic can do it. And because, I don't know if you ever looked up at the bottom, if you swam underwater and looked up at the water above you, it sometimes looks like a mirror.
Yes.
And that's because when light moves from water into air, it should bend. And if you get at a small enough angle, it should bend so as it's back inside the water, so it can't escape the water, so you get a perfect mirror. It's called total internal reflection. And these fibre optics, the light just bounces inside the long, thin piece of glass, and it can't escape. So what he's suggesting is you take a long piece of fibre optic, I guess, put it where one cat's eye should be, somewhere at the beginning of the road, and then sort of run it along the road and come up again where another cat's eye is round the corner or something. I see no reason why it wouldn't work. Fibre optics are quite good. You can get, for the communication, you can get 20 kilometres. You can get light to travel 20 kilometres, and it still be detectable. So you can flash a light at one end, and 20 kilometres away, you can pick up the signal, and that's how a lot of the information on the internet is transferred, in fact, most of it. So I'd see no reason why that wouldn't work. It'd be quite useful, actually, because if you're going around a corner, you'd be able to see the cat's eye. If the cat's eye is lit up from someone else coming around the other way, then you would know there was someone coming the other way. Yeah. It would actually be very good for fog as well, because if you could, the other thing is, you could make it so that if you have your lights pointing downwards, then it went in and lit up the cat's eyes further along, then that would be interesting. I think the big problem would be the amount of glass fibre you'd have to put in the road, and you'd have to dig up the road, and it would be a very kind of complex wiring job. You'd have to go from every single cat's eye to another one 200 yards down the road. Yeah,
but the thing is, though, Dave, that summer will be along soon, and they'll be resurfacing and putting chippings down, and that's they could do it then.
Probably going to be more expensive than a standard chipping job. But, I mean, it sounds plausible. Maybe you should look into it.
Perhaps. Thank you very much. All right, there is a question that's come in here. Not quite sure, but a question for Dave. If humans evolved from apes, why don't apes evolve? Good question.
Well, the very simple question is that apes have evolved, just in a different direction. Lots of people think that evolution is a kind of one-way street from amoeba from little single-celled animals to humans, and we're the ultimate sort of creature of evolution. But that's not at all how it works. Evolution doesn't have an aim in mind. All it's doing is, okay, there's lots of different people. Imagine there's lots of people in the population. We're all a bit different, aren't we? Some people have got red hair, some people have got brown hair, some people are tall, some people are short. Imagine if there was a big flood. And only the very tall people survived because they can stand up and they don't get drowned. Okay, right, it's a stupid idea, but okay. And then the next generation of people are all going to be relatively taller because all their parents were tall, because the only people who survived were the tall ones.
Right. Yeah.
And then slowly the population will get taller and taller. But imagine if the tall people survived and the very small people could also survive because they could climb trees.
Yes.
So you'd end up with two populations. One we'd have a whole lot of tall people and a whole lot of short people. And so if you had lots and lots of floods, then the two populations would separate, and you get the people who are very good at climbing trees, and the people who are very good at being tall and not dying from the flood. Okay, it's a silly idea, but And so basically, there were two different strategies for survival, which are both us and chimps and other apes had a common ancestor a long time ago. And there's one strategy of survival which has worked quite well, which is eating leaves and living in trees, and that's what chimps have done. And there's another one which our ancestors did, which was going out and living in the savannah and running around and sort of learning to use tools. And to be honest, for an awful long time, what looked like the human strategy didn't seem to be doing very well. I mean, there's various evidence that humans our population was down at sort of maybe a few thousand people, which is a tiny population, and then that population since then has expanded. And so at one point it looked like the human strategy was a really bad one.
Yes.
So basically, evolution, anything that survives will all it says is anything that survives will survive. And so everything is evolving all the time. And apes have evolved to be really good at living in trees, and we've evolved to be better at running around on the ground and making tools. It just happens that we've got the making tools has been really useful for various other reasons, and it means we can build cars and planes and guns.
Thank you very much for the question, whoever sent it in. Now, Daniel has sent a question in. He says there are a lot of plants in this very vast world of ours, and he knows that plant leaves contain a green pigment called chlorophyll found in the chloroplasts. But why are some plant leaves in his garden red? Could it be quite a simple one?
I think the reason why some plant leaves are red, I think some poinsettias is apparently one of them.
Yes.
And it's sort of a way of getting attention for their flowers are really rubbish, so they're flat, so they make some of their leaves look impressive, a bit like flower petals, and to attract attention of insects and things. The way they make them red, there's actually still the green chloroplast in the leaves as well. They've just added lots of red pigment. It's the same pigment as is in red cabbage. There's just lots and lots and lots of it, so the leaf looks red. I think, so if in a really bright sunny day, then they'll actually photosynthesize. The green pigments in there will still photosynthesize quite well, and it will still be able to make food, and it'll be great. But in sort of dim conditions, it's probably not quite as efficient as a normal green leaf. So it's will still photosynthesize, but not quite as well as a green leaf. So the plant's kind of saying, the leaf isn't quite as good as a green leaf, but it means that lots of insects will come and find my flower, which is an advantage. There are actually other kinds of chlorophyll in the chloroplasts, which is actually converting the energy from the light and some water and carbon dioxide into sugar. And you don't find them in plants, but you do find them in seaweeds. Because if you notice, a lot of seaweeds are kind of brown or purple colours.
Yes.
That's because they actually have a different kind of chlorophyll, which happens to be red or a red colour. And this can absorb different colours of light slightly differently, which is more useful underwater, because underwater blue light tends to get in much deeper. So they absorb blue light really better, and they absorb red light less well. So there are different types of chlorophyll, but with red plants, then it's just having lots of pigment on top of the chlorophyll, which is there as well.
Well, thank you very much indeed. Howard is a photographer. He says, how can he predict when a decent sunset or sunrise is likely so he can get some good shots with his camera?
Well, I guess the first thing you need for a sunrise is to be able to see the sun, or sunrise or sunset. So the first thing you want to be looking for is a day when it's not cloudy, but that's kind of obvious. I guess what he wants from a nice sunrise is nice deep reds, lots of interesting colours. Now, the way that you tend to get especially deep reds in the sun is you need to, basically, the sun is white. The white light is made of all the colours of the rainbow, everything from violet to red. And so in order to get a nice red sunlight, you need to get rid of all of the blues and the greens and the yellows for to get a really intense sunset. And what does that? That'll happen a bit because you get nitrogen atoms in the atmosphere and a bit of dust in the atmosphere, and those tend to bounce out sort of the shorter wavelengths, the blues and the violets and the greens, more than the reds. So the reds will carry on straight through, and the blues and the greens will bounce out to the side. And that's actually why the sky looks blue, because you're looking at all of the light which is bounced off the dust and the actually air molecules themselves. So if you look at any other direction other than the sun, you see this light which is bounced off, and the sky looks blue or green or bluey, sort of light bluey turquoisey colour. But if you're trying to look for a really good sunset, what you want is as much stuff up in the atmosphere to be scattering the light as possible. So you want really polluted days, so you want to go somewhere that's really nice and polluted. Apparently you get really good sunsets if there's lots of pollution about.
Gosh.
Not too much, so you can't actually see the sun, but quite a lot. So I actually was going around with some science experiments in a lorry once, and I visited Hatfield a couple of months after the Bunfield oil fire. I was talking to a teacher there, and apparently a couple of nights after that oil fire, there were absolutely incredible sunsets in that area because of all the smoke.
Yeah. And
the smoke will tend to let red light go through better than the blues and the greens. So you get so just the red light can get through all the smoke, and so it looks a really deep, exciting sunset colour. It used to be traditionally at harvest time because there'd be lots of dust because everyone was driving tractors up and down through the fields, and that would throw dust up, and that would have the same effect.
What about the sea then? Is the sea throwing up a bit of pollution or something, Aniri? Because you look over the sea there and the sunset's absolutely magnificent.
You do sometimes get little droplets of water being thrown up by the waves, and the water evaporates and you get little salt crystals.
Yeah.
And those are quite important in forming clouds because they're somewhere for water to condense on. So it could be I could believe that they'd be scattering the light as well. I mean, I guess you're looking... You get sunset. And the other thing is that the air over on the east coast will have gone over the whole of Britain, so it's probably relatively polluted already because the prevailing wind directions are coming from the west to the east. So that would have picked up all the pollution from the whole of Britain, and then it'll be sitting over the North Sea for you to look at.
Wow, that's amazing.
And the other thing which can do it is volcanic eruptions. There was quite a big volcanic eruption in Iceland during the 19th century anyway. And that threw up lots of dust into the high atmosphere, into the stratosphere, which produced some nice sunsets. And there was, during the art history, all of a sudden, people suddenly started painting sunsets. There was a whole craze of painting sunsets all of a sudden, and the historians thought people just wanted to paint sunsets then. But actually, if you go back and look at it, there was a big volcanic eruption which threw up lots of dust for 2 or 3 years. So for 2 or 3 years, there were all of these really bright, red, intense sunsets, which then spawned a form of a whole school of painting.
Jackie is on the line. Hello, Jackie.
Hello, Sue.
Hiya. You're through to Dr. Dave. What's your question?
A few weeks ago, you were talking about recycling water. So if I put water in a barrel, put cling film over it, can I then drink it? And does it have nutrients in it?
So if you, when we were building a solar still on the show, whereby if you heat up water, it evaporates, and then if you've got something cold for it to condense on, then it will condense, and you're basically getting very pure water coming out. So what were you thinking of? Was you just any old water, or...?
Yeah, if the rainwater comes down into a barrel and then you then cover it with cling film.
As long as it's not sitting there for too long.
Right.
If it's sitting there, then you get a bit of dust in it, and you might get some little bacteria in it which could conceivably grow. But when it's just condensed, yes, certainly. It's basically it's distilled water. So as long as there's nothing in the water, I mean, if you did the same thing with alcohol, with wine or something, then you'd end up with you get alcohol as well, because alcohol will evaporate as well. In fact, probably it might evaporate first, so you probably get a slightly stronger drink than the wine you started with. But most of the things you're worried about drinking are not going to evaporate very well. I mean, bacteria certainly won't evaporate, and the dangerous and most of the poisons aren't going to evaporate. So unless you've got particularly peculiar set of poisons in your water, then yes, it should be absolutely fine.
So what do you do? It just comes straight down from the sky?
So, in fact, the water which is coming down as rainwater should be drinkable anyway.
Yeah.
Because that's exactly the same things happen to it. It's evaporated off the ground. It's risen up, and as it rises up, it gets colder and it condenses and forms water droplets.
Right.
So exactly the same process has happened to it, just in the air. So in fact, the rainwater is distilled water and should be fine to drink.
So should we not all be doing this then?
I mean, the problem is normally catching it, and if you put up a big sheet on your roof, then you'll get all sorts of dirt and stuff landing on it. And the other big problem is storing it, because the water which you get through your taps has had chlorine added to it, which is basically a very weak bleach, which will kill bacteria. So if there's any nasty waterborne diseases, which are nasty bacteria or amoeba or anything, they get killed by this weak bleach. Whereas if you've got rainwater sitting in a barrel and it sits there for too long, then there's no reason why something can't start growing in it, which could be quite dangerous. So rainwater is absolutely fine as soon as it falls out of the sky, but what happens to it if you've then got a big barrel of it and you've been storing it for a couple of weeks, you're not quite sure what's growing in it.
So could you not put your cling film over
and keep it clean? You could. I think you'd be better off. I mean, you've got to be very, very sure that nothing got in there, because the problem with living things is you only need one of them, and then they can multiply.
Didn't people used to do that with a muslin cloth at some stage? Put muslin over something when they were collecting water from outside
to stop
things
dust.
Getting in it.
Yeah, I mean, it will improve it. I mean, we could do it. I think you'd be better off using rainwater, definitely to start off with, unless you're trying to get completely away from mains water. You're better off using rainwater for things which you're not going to drink. So it's definitely a very, very good idea to use it for flushing loos, washing hands and things, all the sort of grey water. I wouldn't want to suggest that you stored it and then use it for drinking immediately, because you're never quite sure what's growing in it, really.
Why do dogs drink rainwater and not suffer any.
I think dogs. I mean, most of the time we'd probably be fine. It's just a few times when we get you might get a nasty disease. I think dogs tend to have a slightly stronger stomach than we are because they've evolved to be meat eaters for much longer. So they'll be eating sort of half gone off meat when they get hungry. So it's a good. So dogs which can survive eating half gone off meat are going to live longer than dogs which can't. They're going to have more children. So dogs will have evolved stomachs which are better at dealing with diseases which you find in these things. I mean, dogs quite often don't like tap water because they can smell the bleach in it.
Yeah, it's true. I always keep a bowl outside, and they much prefer that, and have it when it's gone off a little while.
Quite often they seem to like water in toilets because that's been sitting there and the chlorine will have evaporated off eventually. Yeah. So they quite often, peculiarly, they seem to prefer that.
Right, Jackie, is that fed your brain for this evening?
That's fine, yeah, that'll do for tonight.
Lovely. Thank you very much indeed for calling. Thank you. Bye-bye. Next up we have Alan. Hello, Alan.
Yes, hello, sir.
Hello there, you're through to Dr. Dave.
Yeah, just on that last subject.
Yes.
In my water barrel, it tends to wash the pollution off the conservatory roof, and I do get a petrol film on the surface of the water in my barrel.
Oh, OK. You live in a fairly built-up area with lots of...
I live in Orpington, and I think, like with the M25, a lot of airborne sort of fumes, and they settle on our conservatory, and that's where we get our water from. And hence we get a kind of rainbow film on the top of the water. Yeah,
that is one problem with the rain. If you get sort of other liquids which will evaporate, like petrol, which I'm guessing you're getting petrol which isn't entirely burnt coming out of some cars.
I was wondering if I got enough of it, I could run my car on it.
Maybe.
You probably could. I guess it's going to be a mixture of petrol and diesel. But those films are incredibly thin. They're thinner than the wavelength of light, so they're going to be less than 1,000th of a millimetre thick.
That was my attempt at a joke, by the way.
Sorry, no, that's cool. I'm sorry. In theory, it would work, but...
In time.
In time. You'd be waiting for a while, I think.
Yeah. My actual question I rang in about is... I understand... and I don't know where I've heard it from, that over a period of, say, nearly every 7 years, the human body's virtually renewed every part of the body in some way or another, because there's this constant sort of replacement of skin and bone and etc. Yeah. It's all going on. But my question is, if that's going on, why is it a scar that I got at 8 years old, I've still got now, I'm in my 60s? How does it just keep renewing scar tissue as well as ordinary tissue?
Good question.
Yes, I think basically the reason your skin keeps growing is I don't know if you've heard of stem cells.
Yes, I've heard of
it. They're quite fashionable at the moment. They're basically cells which can keep reproducing and turn into other kinds of cells. So it appears to be showing me a particularly good scar across the stomach, which is a very impressive scar.
Thank you.
And so the skin cells will keep growing and growing and growing. And so basically, if you've got a skin stem cell at the base of your skin, then that will slowly keep growing and splitting and creating new layers of skin above, and then that will keep going on again and again and again throughout your whole life. But if you get really badly damaged and you get cut badly, your body's reaction to it is that we need to seal this hole up very quickly. We don't really care what seals it up as long as it seals up. And then they use a different kind of tissue called scar tissue, which is much less well organised and just kind of rushes in there and stops the horrible bacteria getting in, because it reduces the chance of infection and things. And so basically you then end up with... scar tissue stem cells, which again keep replenishing themselves rather than the skin cells, and so you're right. The scar will slowly replenish itself. They do tend to die away a bit, so I guess your body does.
Yeah, it does. I think they do fade a bit.
That amazes me that with the idea that the whole thing is the body's being renewed all the time.
Yeah,
that it just keeps renewing it the same as the defects rather than going back to the original skin.
The problem is thinking of how you design the system. It's got to know what was supposed to be there, and your body doesn't really have a set of plans. All it has is a way. It knows kind of how to create a body from a single cell. Your body knows how to make a whole body if it starts off from a little fetus. But if you chopped an arm off, it doesn't have the information on how to make a new arm, sort of starting at the top and working downwards.
Okay, cheers.
Thank you, Alan. Thank you very much indeed. All right, a couple of things here. Eileen from Gillingham rang in to ask if when our TVs go digital, will our radios also have to go digital?
definitely not at the same time. The TV system is different from the radio system. So basically, the radios won't go digital until they turn off the analog signal and start transmitting digital signals over the same bandwidth, the same area frequencies. So not immediately, certainly. They are talking about turning quite a lot of the radio digital because you can get more channels in the same space, which is apparently a good thing. So the government wants to do it at some point, but it's definitely coming after the TVs. I don't have the dates in my head, I'm afraid.
Right, OK, thank you for that. And Tony from Westcliff asked, if you were on the moon, how big or small would Earth look in comparison to the size of the moon when you look at it from Earth?
It would definitely be bigger. It would be about 3.5 times bigger than the moon is from Earth. The Earth is basically 3.5 times larger diameter than the moon. And the distance. So obviously, if you're standing on Earth looking at the moon, it's the same distance if you stand on the moon looking at the Earth. So the Earth would look about 3.5 times bigger than the moon does from the Earth. So yeah, it's
3.5 times.
So yeah, about 3.5 degrees. So if you had a protractor, it would look about 3.5 degrees because the moon's about 1 degree.
Right, OK. Carl asks, why does it get markedly colder just before dawn?
I don't know if it does actually. It will definitely be about the coldest part of the night, sort of basically because the Earth takes a while to cool down. The Earth's got quite a lot of what we call thermal mass. It takes if you have a lump of rock and you put it in a room which is at 0 degrees centigrade, it will take a while for that lump of rock to get cold because it takes a while for all the heat energy to escape from it. And if you've got a really big lump of rock like the Earth, and it will take quite a long time to do that. And so the coldest point of the night is quite a long time after. So the coldest point of the night is a long time after midnight because it takes a long time for the Earth to cool down, and until the sun starts coming out, it doesn't start getting warm. It doesn't start warming up again.
When the sun comes up,
yeah. Well, when the sun comes up, it starts warming up again. But until that point, it's always getting colder because it's losing heat to the sky basically because everything which is warm is glowing in a colour called infrared, and so you're losing energy by light all the time, and so which is the reason if you go out on a very clear night it's very cold because all that energy can go straight out to space and it doesn't come back again. So basically the just before dawn is it's had the longest time to lose all that heat, so it's going to be the coldest time of the night.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.